what I want to start with is just some warm-up activities, because again, I haven't spent a lot of time with trig graphs with you guys, but let's just get the ball rolling. So I'm giving you a trig graph there. Which of the 4 options do you think is correct? You can pop that in the chat. Okay, so the important thing to look for is this value. When theta is 0, what value does the function take on? So you can even look in your calculator. What is the sine of 0? What is the cos of 0? What is the tan of 0? And that should tell you which one fits the drawing in front of you. So this is indeed, the answer is B. It is the cos graph. And if you go on your calculator, you can check by going, what is the cos of 0? And the cos of 0 should give you 1. Okay. Now, some other basics to do with the trig graphs is that trig graphs are periodic, or they have periods, they repeat themselves. And so we can see the period of this graph basically in how long it takes to come back to the same point. So the distance between those two ones is 360 degrees. And so the period of this graph and the period of the sine and cos graph is 360. Now, in trig graphs, we also talk about something else called the step size. And the step size for the sine and cos graphs is just whatever the period is divided by 4. If you deal with the tan graph, it's just whatever the period is divided by 2. And that's because essentially with the sine and cos graphs, they have these 4 pieces that you basically draw them in. So if I was drawing this graph, I draw it by going 0 to 90, 90 to 180, then 270, then to 360. And we really use that a lot when we draw, and we have to draw the graphs from scratch. The other important word that comes up is amplitude. And amplitude is how high or low it goes from its position of rest. And this graph only goes up by 1 or down by 1. So we say the amplitude is 1, and the amplitude is always positive. And then the most basic sort of trig graph, like in this thing, is y equals cos theta. But there are various shifts that we can do to these cos graphs or these trig graphs by going up and down or by stretching them, which we'll get into later in the lesson. Okay, so that was just a little warm-up, throwing some terminology. Let's do another question, though. So, which of these trig graphs do you think this one is? This one looks a bit funky here. It's like, what's going on? So there's a couple of different options that are coming through in the chat, which is good. The 2 most popular ones are A and D. Now, one of the, I'm tempted, I want to provoke a debate here. But what I'm going to say is I totally get why some people are saying sine, but the true sine graph should actually start here and go up to 1 and then down like that, and it should be curling. So it's not actually going to be the sine graph. The cos graph, as we discussed previously, would start here and go down. So it's not that. And the tan graph actually has a completely different look. It goes up like that and down like that. So the only one that remains is D. And so what could this graph actually be? There's actually two options. It could be a sine graph that's been shifted to the left, or sorry, a cos graph that's been shifted to the left. So you can imagine if the cos graph kind of got moved across to there. So you could have a horizontal shifted cos graph, or what you could have had is you could have had a basic sine graph that's been reflected. So you can imagine if you folded it from here down to here. So it could either be a horizontal shift or a reflection, but it's definitely not any of these three that are written here. Give me a thumbs up if you understand why it has to be D, and because I just want to get a feel for, that would, for the class's understanding. Okay, yeah. So it could have been, it's hard to actually know. There could be two right answers for this one, but here it says none of these. So is the correct one in this multiple choice. Okay, let us do this one. What graph is this one? Okay, people are smashing this because this one is kind of like the odd one out, in the sense that the other sine and cos have a period of 360. This one has a period of 180. The other graphs have amplitudes. This one doesn't have an amplitude per se, or it's infinity because it goes up forever and down forever. So it's kind of a bit different in that sense. It also seems to have these dotted lines, whatever these are. Can somebody tell me what these things are? Any ideas? Aha, Chloe, yes. They are called asymptotes. And the graph gets closer and closer, but never gets there. And the asymptotes are at 90, 270, and so on. So the tan graph has what's called asymptotes that the other graphs don't have. Okay. Are there any other things that are different about the tan graph? Well, right now, yeah, that's actually fine for now. So let's move on. So what about this one? What is the equation of this curve? So we're given a choice. Is it A, B, C, or D? Now, this is quite an easy one, so I can see from the chat, this is A. But I want to add to this question. If I say to you, what is the range of the function y equals sine x? What is your answer going to be? What's the range of this graph y equals sine x? You can unmute yourself if you want. Just let me know, or you can pop it in the chat, whatever's easiest. What's the range going to be? Oh, look at my students. One of you is using interval notation, another one's using set notation. We are just winning at life. So it's between -1 and 1, or if we were using this notation, it would be that. And that is the range. It's, the range in which it's existing. It's the y values. Cool. So we've covered the basic terminology. Let us continue on our learning. So next multiple choice question. What effect does the transformation sine x plus 3 have on the graph of the function y equals sine x? Keep those answers coming in. What does this have to do with anything? Okay, so there's quite a few different answers coming in. The most popular, so there's some B's, there's some C's. Most of them, there's quite a few C's. Okay. The important bit to notice is the 3 is not inside of the angle bit. This plus 3 adds on at the end. And so if I had to draw this graph, the correct answer is going to be B. It moves 3 units up. So let me show you why that is. So if I put a 1, 2, 3, 4 there, and a -1, -2 there, and I imagine what the graph of y equals sine x looks like. This will be 90, 180, 270, 360. A normal sine graph will look like that. And it'll have a turning point at 90 and 1 and 270 and -1. Now, what the +3 does is it just moves everything up. Okay, so you can imagine here, it's now going to be there. Everything that was a y value, so here's a y value of 1, this is going to go up to 4. And then it's just going to mimic the shape that it has over here. So that should be much more curvy. And so this would be the graph of y equals sine x. And then the +3 is just moving it up. And so the answer should be B, whereas this one down here is y equals sine x. And this is just over the domain 0 to 360. Thumbs up if you understand that. Thumbs down if I've lost you on the journey. Okay, now some extra questions. I want to know for the second graph, what is the amplitude? What is the range? And what is the period of this second graph? So I'll even highlight it so you know which one I'm talking about. I want to know with this one, what is the amplitude, range, and period? And we'll call that A, B, and C. I like the answers that I'm seeing. Keep them coming. Keep them coming. Now, remember, we're looking at sine x plus 3 here. We're not looking at the original graph. We're looking at y equals sine x plus 3. Okay, so the amplitude is still 1. The amplitude is actually just the number in front, and it's how high or low it goes from the position of rest. And you can see that it only goes up by 1 or down by 1 here. So amplitude is still 1. Range is a bit more exciting. What's the range going to be? Aha. Now, probably the easiest way to write the range is in the interval notation. So basically, it goes between 2 and 4. And you can see this. It goes between 2 and 4. it's basically like if you took the old range, which was -1 to 1, and you added 3 to it, and you get 2 and 4. And the period of the graph is kind of just how long it takes to go completely up and down. And so in that case, the period of the graph is 360. Okay, so I like what I'm seeing. Are there any questions or comments from the class before I move on? Because as you do this, you may have something where you're like, I just want to clarify. And it's a great way now at the end of the year to ask those questions. Otherwise, we can move on. Explain range. Okay. When you have a trig graph, the range is when you go, what y values are involved? So in this second blue graph, can you see that I only ever live between those y values? I'm between the highest I get to is 4, the lowest I get to is 2. Whereas in the earlier graph, the lowest value I got to was -1, the highest value I got to is 1. So the range for the lower one here was between -1 and 1, whereas the range here was between 2 and 4. And I'll come back to range again in later questions. So it's just which y values are involved in that particular graph. Okay, next question. What effect does the minus cos x have on the graph of y equals cos x? We know a normal cos graph looks something like that. That's a normal cos graph. But we want to know, what does this thing do when you compare it to the normal cos graph? Okay, I can see from the chat, many students have said reflection on the x-axis, and you're quite right. What it's going to look like is the minus sign takes whatever was +1, becomes -1. And you can imagine this one over here, -1 becomes a +1. And so that's what it'll look like. It's a reflection across this axis. And so A is the correct option. Yes, we are winning. Okay. Let's keep going with it. Next one. Which of the following points do not lie on the graph of y equals sine x? Which of the following don't lie on the graph of y equals sine x? Now, important, does not lie. Does not lie. So 0, 0 is fine. 270 minus 1 is fine. 180, 0 is fine. The incorrect one is this one, because actually that should have been 91, if you look at that. Yeah. Awesome, awesome, awesome. Let's do This one. Which of the following points do not lie on the tan graph?
Keep going, guys. You're doing great.
I'm throwing in a tan graph because I know it doesn't always get the attention it deserves. Like it's the forgotten trig function. It tries
The
to get
underdog.
Yeah. It looks different, so that everyone just avoids it. It's not good.
Yes.
Okay.
Yeah.
Okay. So which of the following does not lie on the tan graph? So another way to check with this is actually take your calculator and go, what is the tan of 45? Is it 1? Now, it turns out that the tan of 45 is 1. So that's good. 0 is all good. 91, well, 90 is the asymptote. So there's no way that that can be true. And 180 is fine because that's here. So I'm very confident the correct answer is C. All right, let us do a different type of question here. Let's do this one. And then I think we're getting pretty close to having a break. According to the graph below, what is the value of the cos of 120? Now, how would you figure out what that is according to the graph? The 120 would be somewhere, okay, this is in 4, so let's say it's going to be somewhere like around here. Now, I want to know what y value is going to be there. And so what I can see is it has to be negative. Like if I look, if it was above here, it would be positive, but it has to be negative. These are all positive. And so because these are all positive, this one has to be the right answer, which is that one over there. Okay. Yeah. Okay. So from what I'm seeing in the class, I'm seeing a good basic understanding. I want to test your ability to draw graphs, and then I feel like we can go on to sort of like exam type questions. Just before we have our halftime break, are there any areas in particular you want to discuss or bring attention to in the next half an hour and then the lesson on Wednesday? Just take a moment and put in the chat, what are the areas you'd like to top up a little bit about on trig graphs? I'll just give you a minute to pop that in the chat before we have a break. Okay, so shifting of graphs, that is definitely something which we can talk about. Anything else that stands out? Equations with the value of k. Shoshana, do you mean graphs that have a period change in terms of the k values normally associated with that? Okay, cool. No, I think we'll get to that in the second half of the lesson today. Is there a video on drawing graphs from an equation? I think there is, Shane. I'll have to look. Let me think back. If there isn't in grade 11, there's definitely in grade 10 and grade 12 that you can look at. All right. Tell you what, let's have a break because we've been going for quite a long time. And so I think everybody turn your cameras on. Let's stand up. And then Lebo, if you could please shine some light on our wonderful students. And let's stretch it out. Oh, I think.
Please join us in the stretch, guys. Turn on your cameras. Let's see your faces. Shout out to Lesego already joining in.
Oh,
come on, guys. It's been working so hard. Give your mind a break.
Oh, I'm going to stretch my calves. I went to the gym yesterday and I did the calf machine, and now my calves are unhappy.
Oh, no. Was it leg day?
I was just like, when there's so many people on the equipment, you're like, okay, I'll just go and do the calf raise machine. And then you sort of just get going. And I got a bit carried away.
Don't be shy, guys. Let's see your faces. Even if you just flash the camera on for like a second.
So you can say hello. I see those friendly faces. Oh, my neck as well. Give me a neck.
Our people are a bit shy today.
Okay. Oh, final stretch. Roll those shoulders. Then it's time for a really nice brain break. Okay. I have a brain break for you guys that will get your brains, well, hopefully not breaking, but Okay, over to you. There are 12 kids in a classroom. 6 are wearing socks and 4 are wearing shoes. The 3 kids are wearing both. How many have bare feet? And what I'm thinking is that feels like maybe I learned something, a skill that I could use earlier in the year in this class for dividing up collections of people being in groups and in some groups and other groups and in both groups. What mathematical tool do you maybe have that you learned about not so long ago that might be helpful in this question? Dawn, you're onto something. You're onto something. Loretta, I think you. So I'm going to give you a little bit of time to shine here. Think about how that tool that you learned about, how can you connect it to this problem? Okay, in this particular case, I wouldn't go tree diagram because of the number of choices. It's more about like you're trying to collect, kind of work out how many people are there in each group type of thing. I'll give you a little hint to start with. Draw one of these and then draw this situation. Because I want you to think about that and think about what we learned about previously. Aha. Chloe, do you want to explain how you got there? Would you come on for a second? And I agree with you. Tony agrees. Amika, would you be willing to explain? Okay, everyone. Okay. Yeah.
So I drew the Venn diagram, and because 3 kids are wearing both, the 3 goes in the middle. And then because 4 kids are wearing shoes, you say 4 minus 3. So then there's 1 in one circle. And then 6 minus 3 is 3. And then you add that and then minus it from 12 and you get 5.
Perfect. Well done. So absolutely. So basically, once you know this, whatever's left on the outside here is going to be the barefooted people, which is 12 minus 7, which is 5. And so the probability would be 5 out of 12. But in this case, what they're asking for is how many have bare feet. And so 5 students have bare feet in this scenario. Okay. Okay, so maths pops up all over the place. Cool. All right, so give yourself one more shakedown, loosen up your body nicely, and then we're going to go back to some trig graph questions. So we're going to go to some shifting things in a moment, but I want us to just think for a moment, and this is connecting trig graphs a little bit to trig equations. So that's the initial connection. So here is the question. It says, if the sine of x equals 0.122, and the domain you're considering is 0 to 360, what could the x be? What could the x be? So think about sine of x is the graph. This is the graph of that. Which of the 4 options? So Dawn, in this case, it's not a general solution. It could become one, but it's only a specific solution in the range 0 to 360. But that's not really what they want you to do. That what they want you to do is they want you to look at the graph. So you could use your general solution method, but think about what sine of x equals 0.122. I'm going to say that 0.12 is going to be on the y-axis about here. And if you imagine it as a straight line, I want to suggest that, oh, that was getting a bit wonky there, but I want to suggest that y equals 0.122 is going to look a bit like that. So that is the graph of y equals 0.122. So where the two collide is going to be the x value that makes that true. So think about that. If you look, what are the possibilities based on this trig graph and connecting it to the options down here? So this very first answer is going to be probably something around, if I look at the answers, it's either going to be A or B, right? There's no ways it's going to be 187, because that would be down here. And that's not positive because it's going below the line. So for me, I'm ruling out those two because 7 looks like it's in the right part of the world. Now I've got to choose between 187 or 173. And what I see is that my solution occurs before 180. And so if it's before 180, it can't be 187. So I'm crossing that out. And the answer is x is 7 or x is 173. So sometimes we can solve a trig equation using our general solution method in a reference angle, but sometimes we can just see it on a graph. And so the two solutions here, you can see on the graph are 7 and 173 because of the fact that they're the only options that fit. But now, what I want you to do is I want you to take your calculator and go shift sine 0.122. And let's just see that we get, as long as the question's been set up correctly, so shift sine 0.122. And what you see is that you get 7, which makes a lot of sense. Now, I want to point something else out to you. I want to make the connection between the cast diagram and the trig graph. So if I look at the trig graph, the 90 is going to be over here. The 180 is here. The 270 is here. The 360 is here. Do you notice that the sine graph is positive here, negative here, negative here? And if you think of the cast diagram, between 0 and 90, everything is positive. Okay. Between 90 and 180, sine is positive. Between 180 and 270, tan is negative. And between 270 and 360, sorry, not tan. I meant to say, let me say that again. So sine is negative here and negative here. And I just want to ask you, can you see the connection between the graph and where it's positive and negative and the cast diagram where it's positive and negative? Give me a thumbs up if you get that. Okay, that's quite an important idea. And so this is why, when we talk about quadrants and where things are positive or negative, we only have to find the reference angle once, and then you can imagine sine is positive in quadrant 2, but in quadrant 2, it's 180 minus the reference angle, which 180 minus 7 gives me the 173. Okay, before I go down too deep a rabbit hole, let's have a look at another question like this. So if cos of x is equal to 0.64 and your domain is 0 to 360, what could the x be? So this graph is y equals cos x, and I want you to think about the answer not using a general solution here, but using the actual graph itself. How would you visualize 0.64? So I was thinking 0.64 should be like up here somewhere. And so you imagine, when does 0.64 cross into the cos graph? And it looks to me like it has to be, it can't be this one right now. Or it could actually, well, we're not looking at the graph though. It says 0 to 360. Now 50.2 looks reasonable. So all of these could happen. But so this could be 50.2. But now this one over here, this is between 300 and 360. Now the only one that is between 300 and 360 is this 309.8. And so it can't be these two over here. The correct answer has to be B. And this makes sense because the trig equation said to you, when is cos x 0.64, or when is cos x going to be positive? And cos x is positive in quadrant 1 and quadrant 4, or it's positive between 0 and 90. So between 0 and 90, which is here. Well, let me use a different color. So between 0 and 90, it's positive, and between 270 and 360. And so that's why the answers had to be in those spaces, in quadrant 1 and quadrant 4. And again, just to kind of blow your mind again, think about this quadrant, it's positive, then it's negative, then it's negative, then it's positive. And that's why the cast diagram for cos has the shape, where it's positive, negative, negative, positive. So general solutions and graphs actually tie up quite nicely. Okay, let's do another one. And then I kind of Here we've got some shifts going on. So the basic sine graph is shifted. You've got to tell me what type of shift it is. So I'm seeing lots of people now. This, when the x is being subtracted from, that would be what's called a horizontal shift. This would also be a horizontal shift, so it's definitely not one of those two. This is a vertical shift. It's either been shifted up or it's been shifted down. Now, to me, this looks like a sine graph that once was here and then got shifted down. And so the correct answer is A. Just a quick question. What is the range of this graph? And what is the amplitude of this graph? What sine x minus 1? Yep. So range is going to be -2 to 0, or in the other notation, it would be that. And we can clearly see that. And the amplitude isn't changed. The amplitude is still just 1. It's the number in front here. But it's the positive, it's the absolute value of the number in front, I should rather say. Okay. So we'll squeeze one more bit of learning in today, but just a quick thumbs up if you're feeling good, thumbs down if you're feeling a bit lost. Just want to do a quick check-in. Okay. So let's talk now in the last quarter of the lesson about how we can change the basic graphs. So over here, we have the 3 main graphs. Not very exciting. Nothing special has happened to them. Now, so far today, we have done transformations like, say, add 1, where we can shift the whole sine graph up. We've also done some transformations where we have, well, let's actually just do a little conversation here. I want you to draw the graph of 2 sine x in the range 0 to 360. And the way I would do that is I would just draw up my Cartesian plane. I would make markings of however high or low I had to go. And then I would take the period of the graph, which in this case is 360, and chop it up into a step size of 90. I want you to draw this graph for yourself. And then when you are done drawing that graph, I want you to say done in the chat. And then I'll draw in my copy of the graph so you can see if you agree with me. We're going to draw a couple of different, we're going to shift around the basic graphs a bit now. So the normal sine graph would look like this. And it should have, if we were doing this in an exam, we would label the points. But what does this 2 do? It does something different. It's going to change something in the original sine graph. So just let me know in the chat when you're done. So what that 2 is going to do is it's going to change the amplitude, and it's going to go up to a height of 2. The period is still staying the same. And then it goes down to -2, and then up to 2. Now that should be quite curved. So what this number does is it vertically stretches the sine graph. And so this coordinate over here would be 92. And so this is called an amplitude change or vertical stretch. Are there any questions or comments about that shift? Okay. All right. Let's say I now combine this with another type of graph. I want to now draw the graph of y equals 2 sine x minus 1. So I'll do it in black. Y equals 2 sine x minus 1. Now, there are 2 definite changes in this case. And I want you to give you a moment to think about, what do you think that graph is going to look like? And then I want you to draw it. And then once you've drawn it, I want you to say done. So on the board already, we have a graph of sine x, which is the green one. We have the red one, which is this. And now I want you to try and draw y equals 2 sine x minus 1.
You've got this, guys.
We got it. So what happens is the red one has to move down by 1 unit. And then everything that was involved with the red one also has to move down by 1 unit. So that moves down, and then that moves down. Oh, I'm running out of space here. Okay, let's have a look. So first bit is going to be that. And it's going to be that. Then it is, I'm actually running out of space, so that is going to have to go down to here to -3. And then this is going to go back up to that one there. Okay, that looks a bit wonky, and I'm probably trying to squeeze in a little bit too much. But you get the basic idea. Everything has moved down by 1 unit each time. And yeah, I think that is fine for now. Let me ask one more question about the black one here. What is the range? What is the range of this black graph here? And then I think we might begin to finish off for tonight. So I made a new type of graph. I transformed it in 2 ways. I stretched it vertically and I shifted it down. What is the range going to be of this graph? So what's the highest it gets to? What's the lowest it gets to? So the lowest point is -3, and the highest point it gets to is 1. And so that will be -3 through to 1. Okay, so we have covered today, we've done some of the basics of trig graphs. We've also spoken about 2 types of transformation so far. We've spoken about a vertical shift, which is this thing over here. And then we've spoken about an amplitude change or a vertical stretch. Now, these are 2 of the main ones that you deal with in trig graphs, but there are 2 other types of transformations, which I'm going to talk about in the next lesson. The one other type of transformation that we can have is what happens in the situation where the number in front of the x changes. So we have to consider in the next lesson, what happens if that happens? How does that affect the shape of my graph? And then the other thing we need to talk about is what happens if we have to subtract something from inside the bracket. And so those are two situations we need to think about in the next lesson. And what will happen, just to kind of preview it, is this changes the period of the graph, and this will shift the graph horizontally. And so we need to learn how to draw graphs taking into account these shifting sort of parameters. Now, one of the things you can do is you can use your calculator. And so I don't know, just quick show of hands, thumbs up if you've used your calculator for trig graphs before, thumbs down if you haven't. I find the calculator is more useful as a check more than actually me drawing it. But I just want to know how many of you, it's in the table function on your calculator, but I find that in the real world, I just use it as a check. I don't use it that much when I'm drawing. Okay. So just in case you're interested, let me see if I can share this. So I'll say new share. Can you all see my calculator now? Everyone? Thumbs up?
Yes, Mr. S, we can see it.
Is it just the calculator or is it the rest of my screen?
Just the calculator.
Oh, awesome. I didn't know I could do that. Okay. So what you do is you go mode, and then you see where it says table. You click 3 and you click table. And then once you've done that, you click on sign. Okay. And then what you're going to do is you are going to say, well, I need a variable. So I'm going to go alpha x, and then I'm going to close my bracket. So I went into table mode and I did the trig function. Now I go equals. Now I add a second column, but I don't need it right now, so I'm going to ignore it. So where am I going to start? Well, let's say in my situation, I'm starting at 0. So pretend I'm starting at 0 and I want to go, oh wait, start, I'm going to end at 360. And my step size is going to be 90. Then what this does is it gives me the values of the function. So 0, 0, then 91, 180, 0. And I just go down. And this is the sine function, right? So it's very simple. But this can be quite useful when you have more complicated functions, just to kind of check that your answer is on the right track. Okay. So did that make sense? Did everybody kind of know where the calculator function lives now? Just give me a thumbs up if that visualization helped. Yeah. And, maybe play around with it before the next lesson, just so that you kind of, and then after that, when you're done with it, you just go mode again, and then you go back to comp and then 1, and then you're back in computation mode. So it's just a little extra help thing that your calculator can do for you. All right, Lebo, if you could put a link to the poll, please, out for the students. And then I think we've all worked hard enough today. It is time for us all to go and have a break.